In this video, we are going to for EDA tutorial series part 9 Active-HDL. Today we are trying to see what Active-HDL has for us. This tool for FSMs, block diagram simulation, and it's feel good for the simulation waveforms and the handling of the drag and drop approach for the block diagram FSM comparison simulation tool. The structure for this activity is that it's first we have to create a workspace, then under that we have to create a one design, and then we have to add the sources may be VHDL Verilog, then we can have system Verilog as well as block diagram FSMs. In normal way the other tools has a terminology like project, then we have to add sources in that, but here we have to work in this way: workspace, designs and source. So today we are focusing on the drag and drop for the FSM, and there is one very famous sequence detector 1011. So for that, how we can proceed, we will check. Even though we create by using drag and drop, and these are the tools that it offers, like state actions and the conditions, port pins, etc. Again, after that we can have generated code like this for this FSM. It might not be as a industry standard, but for beginning, for large FSMs, one can use this one. Testbench for the same, because we are trying to explore the block diagram approach of this Active-HDL also. So I just create one test bench so that I can plug this test bench to the SD1011 as well as the manually coded Milli and Murray for the 1011. So one test bench can supply all the signals to the three modules, and let's see what we can get. In this way we can connect the block diagrams to there. So we will check in short how we can get this. Okay, and again we can have the simulation waveforms from this Active-HDL, and it is very interactive with the color representation and the back annotation to the block diagram as well. It will show the current values on the buses or signals. So please subscribe my channel and make comments, and please hit like button. Okay, thank you. And we are moving to the Active-HDL. So first of all, I have already created this sequence detector, but for demonstration I will show how we can create basic code. Under that I create, either you can right click, add existing design, or add new design to workspace. So in that it will ask for the empty design, and there are some certain wizards are there, but we go for the default one. Then it will ask the language, like where is the Verilog, VHDL, like that. Also we can have the vendor based chip select for the target. Okay, but we are going for the independent RTL, so we skip this point. We have to give the name of the design, so we are going for the sequence detector FSM, name as Sequence Detector 1011. Just click next. So at the bottom, in that there is one option is there, add new file. You just double click, it will pop up a menu and ask for the what kind of files you want. So Verilog, VHDL Verilog, then state diagrams, system C, block diagram, PSL, source code, system Verilog, like that, but we focusing on this state diagram. So we have, I just kept the same name, just hit OK. It will pop up a template for the Finite State drag and drop option. At the bottom there is a one options for the drag and drop add elements or items. So just I need some inputs, clock reset, then D in and one D out. So that's it. You can change the name like that, clock RST D in D out. Okay, so I make this clock with this link. Okay, either you can have these options synchronous or asynchronous like that, rising, following. Okay, so whatever the standard, I just kept it. Once it is linked, it will automatically having the clock symbol in this clock port pin. So this is reset. Also we can have the reset add this one. Okay, this is D on D out. Generally we kept the output as a registered, so just make it happen that property output, these are the options clocked, we just click it as a register. Okay, inside this palette it will show the some different sign as compared to the others. So just we create some final state. So it is a 4 state. I just click 4 states and have the transaction in between like this. And one reset arrangement, I just pick this reset and just make it happen that condition RST, or you can keep the reset in this way as well, RST. Okay, using this drag and drop options, you can have the whatever the required place some conditions. These are the state actions. At this we need the out should be 0, so in that case 1 dash b 0 semicolon like that. Once you draw all these things, then we can generate the code for it. We just compile it and it will generate a code for it. So for that I just because it little bit take a time, so I don't want to go for the complete designs. I can have that in separate file, so I will show you. So by using the drag and drop, I create this kind of final state, and its name as Sequence Detector. Compile, no, we have to select it as active, so it will have in the bold appearance in this workspace. We just compile it, and at the bottom it will show the if any errors or something like that. So I already checked this design, so it doesn't have any error. In this plus sign you can go inside and you will see there is a Verilog code generated for this sequence detector. So these are the inputs, these are the states, next state logic, and the current state logic, and then registered output logic. Okay, so in this way we can create a final state. You have also the options, right click properties, you can have the numerous options for the final state, registered state, register, reset, then default state actions. Again in the FSM we have code generation settings, in that we can use the if else case construct. Actually design unit name, once it is compiled, or any module that you compile, it will create one block time for it. So in similar way we have to create one next design that like right click on the file or workspace, go to the new design and select some name of it. Okay, so I just create one next design. Verilog, let's say sequence detector test 1011. Okay, under that new design we just click the block diagram approach and give the same name, sequence detector test 1011. It will pop up a block diagram template. So under this icon we can have the compiled. If it is not listed here, you can just click on the what modules you want. Okay, if it is not showing there, you just click the what modules you required in this block diagram. You just double click or activate that module. After that it will show the templates here for the selection. So we need a SQ10. So once you search in this box, it will appear. Okay, we have this block diagram for this. Also I need one test bench for this, so I create one test bench for this already. I need to sequence detector test bench. Just double click and search for sequence detector test bench. Okay, and just drag and drop, just connect it like this, and you can give the name of this nets, this clock, and reset. This is the and we can put a output port here. Okay, at the bottom we will get the output pins, or we can drag it from this, and you can rename like this. Okay, like that. Once this is complete, you can have the compile it. Okay, after that it will generate one Verilog code for the whole part. Once it completed, you can have the plus sign here, and then you have the Verilog code for this test setup. Okay, these are two instances that we are using. For the simulation purpose, you just create one waveform file and then start simulation or initialize simulation. You have to select the top of this simulation. It is a test, this one. You can just drag and drop these signals. You can also change the property of this display size or width. You can have the bold. Okay, just run it for the 100. So this is our output. So we see that 1011, it will detect it, the sequence that we targeted for. In this way we can have the simulation in Active-HDL for the FSM. We can have the block diagram approach as well, so it will somehow easy some type kind of work, and it is very interactive for the having this kind of setup, compile and simulation. So I hope this video is helpful for you, and please subscribe my channel. Thank you.